There's a moment in Death Note that never quite leaves you. Light Yagami sits at his desk. He opens a black notebook. He writes a name. And somewhere in the world, without his hands touching anything, without him leaving his room, without anyone knowing it was him, something happens. The world changes because he wrote something down. Most people watching that scene think about power, about consequence, about morality. But if you watch it the way a programmer watches it, it looks like something else entirely. It looks like code. Because that's exactly what a program is. You write something down, and the machine executes it. Precisely. Completely. Without hesitation, without interpretation, without mercy. What you write is what happens. Nothing more, nothing less. That's the contract. And today you're going to write your first one. Let's start from the very beginning. And I mean the very beginning. Not what is a variable or what is a loop. Before any of that. Before the syntax, before the logic, before any of the mechanics. There's one question that almost nobody actually answers. What is a program? Not in the dictionary sense, in the real sense. What is it actually? Here's the truest way I know to say it. A program is a set of instructions written in a language that a computer can understand, executed in a specific order to produce a specific result. That's it. That's the whole thing. But let's pull that apart because each word in that definition is carrying weight. Instructions, not suggestions, not guidelines. Instructions. When you write code, you are not asking the computer to do something. You are telling it. And computers are, at their core, completely literal. They will do exactly what you wrote. Not what you meant, not what you probably meant, not what any reasonable person would have assumed you meant. What you wrote. This is the first thing that trips up almost every beginner. Not the syntax, not the logic, but the mindset. You have to start thinking with the precision of light writing in the Death Note. Every character matters. Every symbol has a purpose. There is no room for ambiguity because the machine has none. In a language the computer can understand. This is the second piece. Computers don't actually speak C++. They speak in binary, ones and zeros, electrical signals, pure machine logic. C++ is a human language. A language designed to be readable by people, but translatable by a program called a compiler into something the machine can execute. We'll talk much more about compilers later in this arc. For now, just know, C++ is your bridge. It's the closest to the machine you can get while still writing something that feels like language. Executed in a specific order. This one is subtle but critical. Your program runs top to bottom, line by line, instruction by instruction, unless you tell it otherwise. Sequence matters, order matters. A recipe where you put the eggs in before you crack them isn't a recipe. It's chaos. Same with code. Now here's where it gets interesting. Humans have been giving instructions to other humans for as long as civilization has existed. A general gives orders to soldiers. A chef writes a recipe. A composer writes a score. Light Yagami commands people to die. All of these are, in some sense, programs. A set of instructions, in order, designed to produce a result. But every one of those has a problem. The people executing them interpret. A soldier uses judgment. A chef improvises with what's available. A musician puts feeling into the notes. L finds a loophole and refuses to die. That is what you wished would have happened, right? Joke's on you, because that is not happening. Anyway, they all fill in the gaps. They adapt. A computer doesn't. A computer follows your instructions with zero interpretation, zero improvisation, zero gap filling. If you left something out, it doesn't figure it out. It fails. Or worse, it does something completely wrong without telling you. This is what makes programming both harder and more powerful than any other form of instruction-giving humans have ever invented. The machine is perfectly obedient, but it's only as good as what you gave it. Light Yagami understood this. The Death Note wasn't powerful because it was magic. It was powerful because it was precise. Write a name and the outcome follows. No interpretation, no deviation. The notebook executes. You are about to write your first instruction to a machine that will execute it the same way. So, what does that actually look like? Let's talk about the structure of a C++ program before we write a single line. Because structure is everything. A program isn't just a list of commands thrown together. It has architecture. It has a shape. Every C++ program you will ever write, from a beginner's first exercise to a system running a satellite, has the same fundamental skeleton. And that skeleton has 3 parts. Here it is, the skeleton. First, the includes. At the top of your file, you tell the program which tools it's allowed to use. C++ doesn't give you everything by default. You have to ask for it. If you want to display text on screen, you need to include a library called IO stream, which stands for Input-Output Stream. Think of it like telling your kitchen, I need the stove today, make it available. Second, the namespace. C++ is a massive language used by millions of developers around the world, and a lot of them name their tools the same thing. To avoid confusion, C++ organizes tools into namespaces, like labeled rooms in a building. The standard tools live in a namespace called std. When you write using namespace std, you're telling the compiler, I'm going to be working in the standard room. You don't have to keep specifying it every time I reach for something. Third, the main function. This is the entry point. When you run your program, the computer doesn't know where to start, unless you tell it. The main function is that starting point. It's the first room you walk into. Everything begins here. That's the skeleton. That's the shape of every C++ program at its most essential. 3 lines of setup, a pair of curly braces, and inside those braces, a world you get to build. The return 0 at the end is a message to the operating system. 0 means everything went fine, no errors, mission complete. You'll write return 0 at the end of main for a very long time. It becomes muscle memory. And that comment, the line that starts with // that's a note to yourself. The compiler ignores it completely. It's how you leave messages inside the code, explanations for anyone reading it later, including future you 6 months from now wondering what you were thinking. Now, let's put something inside that skeleton. Let's make it do something. The most famous first program in the history of programming is called Hello World. It's a tradition. Every programmer on Earth has written it at least once. It's the handshake. It's the moment the machine says back to you, I hear you. Cout is your output tool. The name stands for character output. It's the stream that connects your program to the screen. The less than operator is how you push something into that stream. Think of it as an arrow pointing toward the output. And ENDL ends the line, moving the cursor to the next line. It's like pressing enter. Run this program, and the screen prints. Hello world. That's it. That's your first instruction. You wrote it. The machine executed it exactly as written. No interpretation. No deviation. You just wrote in the notebook. Now, let's make it yours. Because Hello World is a tradition, but it's not a statement. Let's do something slightly more intentional. Notice what happened. 2 cout statements, 2 lines of output. The program ran them in order, first line, then second line. Top to bottom. Exactly as written. This is sequence, the most fundamental concept in all of programming. Before conditions, before loops, before functions, there is sequence. Instructions happen in the order you write them. This seems obvious right now, but the moment you start writing more complex programs, you'll realize how much of your job as a programmer is thinking carefully about order. What needs to happen first? What depends on what? What would break if you swapped these 2 lines? Light Yagami was meticulous about this. He didn't just write names randomly, he orchestrated, he sequenced, he thought about order in a way that made every outcome feel inevitable. That's the mindset you're building. Let's go one step further. Let's talk about what it means for a program to communicate. Not just output text, but take something in. Right now, your program is a monologue. It speaks, it doesn't listen. But most real programs are conversations. They take input from the outside world and respond to it. See in is the counterpart to see out, character input. The greater than operator pulls something from the input stream into your variable. And string is a data type, a way of storing text. We'll go deep on data types in the next episode, but for now, just know. String name creates a container called name that holds whatever text the user types. Run this, type your name, and the program greets you back. This is the moment a program stops being a static script and starts being alive. It responds. It reacts. The output changes depending on the input. This is the foundation of every interactive program ever built. Every game, every app, every website. Input goes in, logic runs, output comes out. The Death Note had a basic input. Light wrote and the outcome was fixed. But real programs, powerful programs, respond to the world around them. They adapt, they process, they decide. You've just taken the first step toward building something that does all three. Here's the insight that most people miss at this stage, and it's the one I want you to carry into everything that follows. Writing code is not about memorizing syntax. Syntax is just vocabulary. You'll learn it the way you learn any language, through use, through repetition, through making mistakes and correcting them. What matters right now is not that you memorize every symbol in these examples. What matters is that you understand what's actually happening. A program is a conversation between you and a machine. You write in a language precise enough that the machine can understand it. The machine executes your words exactly. And the world changes. Even just a little, Chasen, because you wrote something down. Every application on your phone was written this way. The software that flies planes, that processes medical images, that routes your messages across the internet. All of it started as someone sitting down and writing instructions. Precise, ordered, intentional instructions. You are now someone who does that. You've learned that computers are perfectly obedient and perfectly literal. You've learned that structure matters, that a C++ program has a shape, a skeleton, a specific architecture that everything else is built on. You've learned that sequence is fundamental, that order is not incidental, it's everything. And you've learned that a program can listen, not just speak. Light Yagami's power wasn't the notebook. The notebook was just a tool. His power was precision, the ability to write something with absolute clarity and trust that it would execute without deviation. That's what you just learned to do.
Domain expand.